bam, bam. Oh my goodness. Hola. I'm recording, I'm pausing. Good start. Who said that? Oh, there's somebody else. All right. More people. All right, guys. So today is the quiz on, what's this? Veronica says 15. Okay. Let me try to remember. 6-1 through 6-4, I think it was. Is that what it made it? Yes. I'm pretty sure. Yes. And then we'll have another quiz on the last 3 in chapter 6, because the last 3 parts of chapter 6 are kind of big. We got a little bit into that yesterday with the teaser about dividing polynomials. So that in itself is going to take a little while to get used to. I've put up on Canvas, let me show you guys. Let me see. Hold on, here we go. My share screen was really freaking out this morning. Let's see what happens. All right, I don't know. What do you guys, can you guys see Canvas right now? Over here? Anybody?
I see. Yes, I see.
Yes.
All right, good. Because on my screen it's like something else, but oh well. Let me see what I'm trying to say. So if you go to pages, let me see if that's where I put it. Yeah, see here, right here, section 6.5 and 6.6. And it's a little handout. Let me see, it looks like this. Let me pull up this one, it's a little better.
Yes.
It's got some notes about dividing polynomials. So down here is where we get into the long division stuff. So I just want you guys to have that as a reference for when you're doing those problems. Okay, so that's up there. That's something new. The quiz will be activated after this lecture. Does anybody have any questions from homework or anything? Is homework going okay? You guys still doing the homework and turning it in? I am a little behind on looking at stuff, so I'm hoping I'll be able to get in there soon. I'm on a few committees that are trying to figure out exactly what courses we can offer over the summer and the fall with the weirdness. So it's been a little bit hectic. Let me turn off my T-Rex. Sorry, Toby.
Okay. Excuse me.
Yes.
6.5 and 6.6. What is that? The pages? Is exercise?
No. Let me show you again. Let me see if I can't pull it back up. Hold on. Let me get that out of the way. All right. Show you this here. Hold on. Today would be good. Computer, hello. Oh, crap. All right, give me a minute. Old man using technology. Wait a minute. All right, this is not it. All right. Hold on.
Take your time.
Here we go. Ah, crap. Ah! Oh, it's been that kind of day, man. All right, here it is. Yay. Okay, so you see the Math 90 page? Let me make it a student view. So this is exactly what it looks like to you when you log in, right? If you go to pages, see pages right there? This wasn't really an assignment. Uh-oh, am I still, okay. Did I just blip out? Tell me if my Wi-Fi goes freaky. It's been good all day so far. Go to pages, right here, go to pages. I'm gonna have to say all this again in a minute. More people just came in. So if you go to Canvas, go to pages, see it says section 6566. There's also the photo to PDF list of, uh-oh. Are you guys still with me? Okay.
Yes.
It's glitching on my side, so I don't know. The photo to PDF collection of applications for scanning things to PDF. I think I got too many things open. Is that true, Jeff? It might be true. All right, And section 6566, that is a handout that looks like this. And it's just got some problems I think I'm going to try to do with you guys in a minute. And then it's got some notes down here related to the other stuff we're going to get into, the long division of polynomials. Okay. So, I mean, you should keep up with Canvas. Notice when there's things that change. And you should keep up with YouTube. Notice when I post things to YouTube. Okay. So let me stop sharing for a minute. Any questions on anything we just discussed? Any questions on any homework stuff? Anybody? Everybody's good? Okay.
Yeah, you give.
Oh, sorry. I just muted you. Ma'am, go ahead.
Yeah, you give us an example for the pages, 6.5 and 6.6. I see already, but we have to do it. I mean.
Is it an assignment?
Yes.
Nope. It's a page. So we're going to do some of them together, and then at the end there's an example of the long division thing that we haven't even talked about yet. So this is not an assignment. You've got your own homework to worry about. I'm going to not try to give you
just exercise for us.
Yeah, just like I would have given this worksheet out in class, and I can't do that.
Okay, I got it.
So this is me giving it out in class. Okay. All right. All right, so nothing from homework, right? Everybody's good. Homework is going fantastically. I like it. My hair is appropriately insane. All right, let me see. Yes, okay. So if there's no questions, I'm going to get right back into where we stopped, where we left off. Just remind everybody, just remind you guys, there is a quiz today. So as soon as the lecture's over, it'll be active on Canvas. It's quiz 6. So it will be due by tonight, by 11:59 tonight.
I do have a question.
Yes.
It's 6.5, number 474. Are we in 6.5 yet?
Yes.
Number 474.
470.
I just didn't understand how to divide it with a y plus 3 underneath.
Hold on, let me see. Sorry. Wow. Which one again? Sorry.
474.
474. Okay. Wait a minute. That's 6.6.
Wait, am I doing the wrong? Oh.
Yeah, we haven't talked about 6.6 yet.
Oh yeah, it is 6.6. My bad.
Not the last part of 6. Okay, good. Thank God. I was like, why did they put a problem like that in the last section? Okay, they didn't. Good. All right. Anything else? Anybody? Okay, so let's start off with another example of straight up long division of numbers, right? Yaksha, I don't know how you're dealing with everything happening over there. Okay, you're a mom, so you're like, I'm used to it, don't worry. So let's do this. This is something like we did yesterday, right? And there's a reason, there is always a reason, believe it or not. It's not ever because I'm going insane, not yet. Give me a few more years. We did a problem like this yesterday, right? Let me kind of pin my video here. Oh, so just, let's do this together. All right. So you're not allowed to use a calculator on this. So what would be your first step?
6.
Yeah, why? Because now, I really want you guys to notice that this is true. You don't look at 62 into 389. You think 6 into 38, don't you? Do you think the first part into the first part? Because that's a really good way to get a good guess. So then you put a 6 down because 6 times 6 is 36, right? Now, do I just do 6 times 6? No, I do 6 times 62. 6 times 62, 372. Right? And then I change the sign, right? There's a reason I say it that weird way. So we subtract, but another way I could look at it is I change the sign. And then I get 1, 7, and then I bring down the 4. 6 goes into 17 twice. Oh, this is neat. I wish I could say I did this on purpose. Do you know, I mean, 2 times 62 is, what is that, 124? Somebody with me so far? Oops. And then I can write that as
Yes.
50 over 62, which would actually reduce, but I don't care about that right now. So I almost got 62 squared there. That's kind of neat. Anyway. So now watch this. All right, let's do this. This is going to be nifty. Let's do this. You ready? Pull this up here. So let's do this problem. Let's start off small. Let's see. Sure. Oh boy. Oh shit, Jeff. What I want you guys to realize, my hair is going to drive me crazy. Oh well, too bad. Is that all right? Yeah. All right. 62 is 60 plus 2. Isn't that amazing? 62 is 60 plus 2. I know this is really strange, but I want to show you why this still makes sense. So the first thing we did on this problem was we looked at the 6 to go into 38. We looked at the first part to go into the first part. Veronica, just stay with me. The thing we do with polynomials is exactly the same thing we do with numbers. So this will look more difficult, but it is the same level as this. It is. So stay with me now. Is everybody decent with the fact that you did 6 into 38, right? Every single one of you did 6 into 38. Not a damn one of you did 62 into 389. Don't even try to give me that shit. And you go, I know my 62's times table. No, you don't. Be quiet. Right? And I'm not coming down on you because I did the same damn thing. I did 6 into 38 also. Of course I did. So what's my point with that? So here I've got x plus 1, the same way I had 60 plus 2 down there, right? So let me see. X goes into x squared how many times? X times what is x squared? The same way we did 6 times 6 is close to 38, right? X times what is x squared?
X times 2.
X times 2 is 2x. X times what is x squared?
X, another X.
Another x, right? Okay, I like it. Let me stop for a minute. Let me write this in a different color even. Let's try this out. Let's see. Ooh, Jeff. Ooh, yeah. Let me just stop for a minute. I really desperately want you guys. This problem had to be okay. I know I talked about it in a little bit different way than you're used to because I was trying to get us ready for this. 6 into 38 goes 6 times. Then I did 6 times 62 and wrote it down. X times what is x squared? I'm just going to worry about the first parts. I'm just going to worry about these. The same way I just worried about those.
X2.
Yeah. So, okay, I'm with you. That's how I got an x up here, right? X times x is x squared. 6 times 6 is close to 38. It's the same idea, right? So now what's x times x? X squared. And what's x times 1?
X1.
X, right?
Yes.
Same way I did 6 times 62 is 372. 360 plus 12. And now I do the exact, what did I do next down here? The minute I wrote 6 times 62 is 372, what did I do? Change the sign. Exactly. So what I'm going to do up here with even another color Oh my gosh, what happened to you? You poor thing. Red, come back. Okay. Do you guys see that? I'm going to subtract it. So I'm going to change their signs. Because I would write it like this, but this is kind of gross. I just want to skip this step. Minus this. Well, why don't I just distribute it in the first place so I don't have to write all this extra crap? Just change both their signs. So again, 6 times 6. Okay, so 6 times 62. Write that there. Change the sign. Combine these, right? So combine these. What's x squared minus x squared? Gone, right? That's always going to happen with this. The first thing is always going to cancel. What's negative 2x minus x?
1
3x.
minus.
Negative 3x.
And then bring down the negative 2. All right, let me stop. You are not used to seeing it like this because you are not used to like 60 plus 2. Can I combine those? Yeah. So that's why we do. We combine them. X plus 1. Can I combine those? No. But thankfully, the process stays the same. You have to try to see that. Every step I've taken up here so far is the exact same kind of step I took down here. Don't worry, we'll do another example. Let me move this one out of the way. Go away. Keeping going. Now, what's the next thing I do? X times what is negative 3x? Isn't that the next thing I do? X times what is negative 3x?
Negative 3.
Right? What is it missing to become a negative 3x? It's missing a negative 3. So what's negative 3 times x? Negative 3x. What's negative 3 times 1? Negative 3. And then what do I do there?
Changes the
Back
sign.
in the place where I
Oh. All right. And again, we're going to do another example in a minute. Right? So don't give up yet. How many of these have you seen so far? Not even one yet. We're not done with the first one. So why give up immediately? That makes no sense. So come on. These cancel. Negative 2 plus 3 is 1. And now watch this. Exactly the same way it worked with the numbers. I can write down here plus 1 over x plus 1. Okay. Now watch this real quick. We did this last time. We did this yesterday. Can somebody do x plus 1 times x minus 3? Right? You guys see where I got that from? X plus 1 times x minus 3. I'm going to kind of start to check this. I see I'm off by 1, right? So let's see what we get when we do x plus 1 times x minus 3. We'll get x squared minus 3x plus x minus 3. How far off is that? Oh, shoot and a half. There we go. How far off is that from this? They're not the same, right? How far off are they from each other?
Negative 1.
They're 1 apart, right? There's 1 off. This is 1 more than that. That's the remainder. That's the remainder 1. Okay. Let's do another one. So all this work right here, this is the answer. This is the answer, and then this is me checking the answer. How do you check a division problem? You multiply, right? You see if what you got makes what you needed to get, right? Okay, let's try another one. I keep forgetting I have a real eraser now. Oh well. Where's my eraser? There it is. Yay! All right. So let's look at this one. What you got, Jeff? All right. So, again, same steps. You look at the first piece of this and the first piece of this. And you say, what do you have to multiply this by to make this? What do you have to multiply x squared by to make this?
X.
Yeah. Never mind. Is everybody with me out there? Okay, I can see a few of you guys. Hopefully the rest of you guys are really actually there. That'd be great. All right, I'll stop. So x squared times x. And just to remind you, let me do real quick down here, look. Yeah. What's the first step in this? 7 times what is 43? Well, 6 is the closest I can get, right? Okay, so we're doing exactly x squared times what is x cubed? X squared times x is x cubed, right? So keep it on going here. Let's see. And then x times these. What's x times x squared? Of course it's x cubed. X times -3. Now watch this. You got to be careful. It's going to be -3x, right? So if you want to be nice to yourself, you're going to put that along with its like terms. Do you guys see that? I might have taken too big of a jump on example number 2, but all right, I'll step it back here in a minute. But you can be nice to yourself and line up the like terms. So let's put these stuff together. What I have to do before I start combining things, this is the step that students miss sometimes. I have to change the signs, right? I have to subtract those. I got to change their signs. What's x cubed minus x cubed? Dead. What's 5x squared plus nothing? What's -2x plus 3x? And that can bring down the 1. Let me stop for a minute.
I don't understand.
What's up? Sorry?
I don't understand. Can you do it again?
We'll do another example, yeah.
Okay.
Well, let me see. I'll start over here. Let me see. So, the first step of any division problem is to look at the first parts to see what to put up here as a good first step, right? That's just the reality. So again, if I had to do 22 into 8,947, right? If I had to do this problem, 2 goes into 8 4 times, right? So 4 is a good first, guess, a good thing to try. So I looked 2 into 8, didn't I? And then 4 times 22 is 88, and then I change the sign, and then I put those, and then I bring this down. Does 2 go into 1? No, so I need another, right? I mean, that's, right? And then you put a 0. I don't know if you guys remember all that. That might be, remember that? That could come up here. Okay, so let me keep that there for a minute. First step was 2 into 8, goes 4 times, and then 4 times 22. First step, x squared times what is x cubed? Same way I did 2 times what is 8? 4, and that's why I put a 4 up there. So x squared times what is x cubed? X squared times x is x cubed. That's the exact same step as when I wrote that 4 right there. It's exactly the same thing. 2 times what is 8? 4. All right. And then what did I do next? I did 4 times 22. So I'm going to do x times this. X times x squared is x cubed. X times -3. Oops. And see, I want to put it with this like term, right? -3x. Then I change the signs, right? I gotta subtract, right? I gotta do this part. Change the signs. X cubed minus x cubed is nothing, it's gone. 5x squared and 0 is 5x squared. Negative 2x plus 3x is x. And then I can bring down the 1.
Okay, why you put the 3x, you put it on the 2x? Why you don't put it on 5x?
Because are these like terms?
Oh, no, because that, okay, I got it.
It's kind of funny because it's sort of the same thing down here. It's not a perfect analogy, but there's watch this real quick. Just let me see if you guys understand this. This is kind of a cool idea. What does this 0 mean right there? What does that 0 mean? It might be a very strange question, but
104.
okay, I like it. What does that 1 mean?
100.
100. What's that 4 mean? 4 ones. What does that 0 mean?
Hundreds.
1 is 100s. The next place is tens. So what does that 0 mean? No tens. I don't. This isn't anything. Are you guys concerned that this has something to do with this problem? Just I'm gonna bring it in. This is by itself right now. Just by itself. What does that 0 represent? There are no tens, right? Isn't that what that 0 represents? Don't look at me like I'm crazy. Some of you guys look at me like I'm crazy. What is this? What does that 0 mean? What does that 0 mean?
Hundreds.
Hundreds. There's no hundreds, right? There's 5,000s, there's 2 tens, and there's 4 ones, but there's no hundreds. Now, some of you guys might be looking at me like the way you are because you're like, what the shit is this? All right, so give me a second. Sorry, little kids. Are there any little kids? Don't bring little kids in the room when you got me on the TV, on the laptop. Are you kidding me? Do you see how x squared minus 3, do you see how polynomials are missing something that numbers have? How many x squares are there in this statement?
2.
No. How many x squares? There's 1 x squared.
1 square.
How many ones are there? 3. How many x's are there?
2.
No. Okay. Let me write a different thing. How many x cubes are there?
6.
How many x
Oh,
cubes?
5.
There's 5. How many x squares are there?
6.
6. How many x's are there?
0.
None. You guys
None.
see that? I love you guys. You can stay with me now. Do you guys see what I am saying right now? I can see how many x cubes there are, how many x squares there are. Why can't I see the x's? Because what is 0x? 0. And why would I write it down? But to be fair, right, if I wrote 1,337, that looks like 137, right? Stay with me. Come on. I know this is weird. So we had to come up with the symbol to represent the absence of those. Do I need that same thing? Do I need this here? Do I really need this here? No. That means the same thing as this does, right? But the fact that polynomials don't have zeros that show up, that's a 0. That's what that is. That's a 0. There isn't any x squares. There's a 0 here. So that's kind of weird why we have to move that over. But it's because the plus 0 stuff is not even showing up normally. All right, I don't know how many of you guys came with me. If you didn't like that whole explanation, just go with the very first thing I said, which is line up your like terms. X times -3 is -3x. Oh shit, it's not like terms of that. I better put it over here. How's that? Is that so? One of those two explanations has to make sense. All right, now. And then, so we did x times x squared is x cubed, x times -3 is -3x, and then I changed those signs. That's the subtraction step. Do you guys, I need you to really understand this. This isn't me going insane. This is the reality. Every step we're doing right now is the exact same steps we did when there were only numbers in it. That is the absolute truth. All right. All right. So continuing on. X squared times what is 5x squared? Isn't that the next step? X squared times what is 5x squared?
So I know we should multiply 5. Yeah, but why not is a -5?
Because that wouldn't make 5x squared. If that was -5x squared,
Oh,
then
we
it would
have
be
to make
negative.
a 5x
Yeah, we have to make this.
square. Oh,
Yeah,
so
yeah.
just yeah, +5.
Oh yeah, right. And so, all right. So again, if I had, let's see, what do you got, Jeff? Let's do something even more deadly here. 847 into 7,367. Let's make it even better. There you go. A few more numbers. Why not? Okay. Yeah, baby. You want to do this long division. I know you do. So how would I do this? I'm not going to do 847 into 7,003. No, I'm not going to do that shit. I don't know that. I'm going to do 8 into 73. Right? How many times does 8 go into 73? Now this might be the, let me make this, give me a second. I don't want to make this more confusing. Let's do this. Yeah, all right. Just so there's nothing weird that happens. How many times does 8 go into 71? That is me doing this into this, and that is exactly how you guys would do this problem if you did it by hand. There's nobody in the universe that knows the 847 times tables. Well, you never know. It could be some weird guy. 8 times what is 71? Roughly.
8.
8. So 8 times 847. Oh shit. So 6, 5, 7, 3, 67. I think that's what it is. Is that right? 6720. Yeah, 6776. I like it. All right, let me stop for a second. I mean, isn't that exactly everything we did up here? 8 into 71. The first part's x squared times what is x cubed? 8 times what is 71? Same first steps, right? It's just this is actually a little bit cleaner. You can always kind of make it become exactly this. And then x, and then we did 8 times 847, and we got this. So we got to do x times x squared minus 3, and we got these. Then I change the sign, bam, bam. Combine, so this one I would get 391, is that right? Sounds good, doesn't it? I think it's right. Anyway. You guys, now. Looking at this. This is old news. You should be able, if I gave you a problem like this, you should go, oh, good. I can do this shit. What's the next thing? And again, this is kind of gross. Oh, yeah, I forgot to bring down the 5. Right? So now what's the next thing you would look at? 8
4.
into 39, right? Do you guys see what I'm saying? You would look at 8 into 39. And that's 4.
4.
And then 4 times this mess. I don't know what that would be. 3350. Well, I'm going to actually try to do this. Why am I doing this to myself? 38, 3350. Is it 3388? 4 times this? Let's pretend like it is. I don't know. And then you just do the whole process again. You just keep going. Okay. So maybe I should, let's do this. Maybe I should force you to do some of these yourself instead of just watching me. All right, everybody out there right now, do this. We'll finish this problem in a minute. Everybody out there right now, do this problem. What do you got, Jeff? Do this long division by hand. Because if you're not able to do this, you will never be able to do this. Because everything I'm talking about up here is the exact same steps you do for this. Now, let me check in. Anybody do long division differently than this? Were you taught differently if you were if you grew up in a different country? Because I have seen other formats for doing long division of numbers, but normally it's my Russian students have a different way they set up the division. Believe it or not. Are you guys working on this? I can see a few of you guys. The rest of you could be anywhere. Somebody just left, in fact. They were like, you keep accusing me of being somewhere, so I'm just going to go. I'm like, all right, shit. All right. Anybody have the answer yet? I can't, no. I see x minus 7 or something. All right, let's see. Let's try this out. 4 goes into 9 twice. Two times 41 is 82. Right? Then I change the sign. So then this will be, what do you get? Get out of there, Jeff. There you go, buddy. Bring down the 5. Now this happened to be, coincidentally, 4 goes into 8 twice. 2 times 41. Well, there's Alex coming back. 2 times 41 is 82. Change the sign. And then I would write this 36 over 41. So that is a process you have to know how to do. You just have to know how to do long division, because what we're doing now is the next level of long division, which is how do I long divide variable expressions? Oh, that's all right, Savannah. I'll post the video. Okay. So coming back to this, I'll tell you what. Well, let's finish this up, and then I'll do a little bit of an easier problem. All right, I took a bit of a big step. So everybody got this here? So again, if you forgot how to long divide, you're going to want to do some long division, because the better you remember that, the easier this is going to be. Because again, every step we do here is exactly the same step we did here. They just look different because up here I don't know all the numbers. Some of them are unknowns, x's. So finishing this up, x squared times what is 5x squared? What times x squared is 5x squared?
Just 5.
Yeah. I just noticed your question. No, I'm sorry. I don't remember now. I erased it.
No, I was wrong.
Okay. Does everybody see that? X squared times what is x cubed? X. No. X squared times what is 5x squared? 5. 5 times x squared is 5x squared. 5 times negative 3 is minus 15. Let me line those up, right? It's not like terms for this one. And then I change the sign. These cancel. They always will. They cancel. X is still here. Plus 16. Now, notice. Do you see how that's got a higher power than this? That's how I know I'm done. Because x squared can't go into x. It's got a higher power. So then I would write plus this over this. Okay. So let's do one more, and then I'll call it a day for all of us. All right. And again, I know this is nothing you've ever had to do. I know that you guys really don't like long division in the first place. You loved, and I'm not saying anything derogatory about it because I felt the same way. Long division is a drudgery. It's like, okay, but we have to know how it works, because can you put this in your calculator? No. So we have to be able to do this. I know we could put the other one we did, the one we did here, we could put that in the calculator, and you're probably like, why the hell would I do that shit, Jeff? We have this thing we invented called a calculator. But if we forgot how those work, we can't possibly do more interesting ones like this. And if you're like, well, I don't want to be able to do that, well, I'm like, you probably have to be able to pass the class. So you should be motivated. Let's try one that's not as freaky. Let's try one nice and concise here. All right, that one's a nice one. He's nice. So to get it started, you look at 2x times what is 4x squared?
2x.
2x, right? 2 to make 4, and another x to make x squared. Then I multiply this by this whole thing. 2x times 2x is, of course, 4x squared, right? That's where it came from. That's why I put it there.
4x squared.
And then 2x times negative 1 is negative 2x. And before I combine anything, what do I have to do?
Minus.
Yes, change the signs, right? Because I would subtract that whole thing, so then the negative would distribute. So you just change the signs. And then you combine them. And again, if you do not believe me that every step we're doing is the same, if I had all numbers in here, it's exactly the same steps. It just is. And then I combine these. These cancel like they always should.
0.
6x plus 2x, 8x.
Plus 8x.
Yeah, minus, and then you can bring down the minus 8, right?
Yes, yes.
2x times what is 8x?
Times 4.
4. So you put plus 4, right?
Yes.
And then you multiply that to each of these. 4 times 2x.
8.
4 times negative 1.
4.
Yeah.
Good. I can see the bottom. Thank you. Just like this.
You got something going on in the background, Liam?
I got it. That one cancel. 1x.
No. Come on. Change the
Minus
signs.
0.
Change the signs. 8x minus 8x is 0.
0.
Negative 8 plus 4.
4.
Negative 4.
Minus 4. Negative 4. Got it.
Then up here I can put minus 4 over 2x minus 1. That's the remainder. In that step is exactly the same as if it was just numbers. Every single step in this process is the same as if it was just numbers.
Oh, it's gonna be 2x in the bottom, 2x what?
This.
4, yeah, 4 in the bottom, 2x,
Yes,
yes.
this.
Oh, the
This
same.
is on the bottom,
I
as
got it.
always, right?
Yes, 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 yes.
Just to remind you guys, a really quick little tiny one. If I did 6 into 19, if I did 6 into 19, right? It goes 3 times. 3 and 1/6. Isn't that how I'd write that? 1/6, bam. So it's this over this, bam, right? That last step is exactly the same also. Right? 1/6, bam. Negative 4 over 2x minus 1, bam. Right? It's the exact same step. Alex, are you okay out there? I think you froze or something. Hopefully you're still there. You look like you're eternally slapping your head. I'm sorry, man. All right. Maybe that's enough new stuff for today, huh? Maybe? For whoever's out there?
Yes, please.
Okay. All right.
Thank you.
So can everybody
That's a
who's here,
yes.
everybody who's here right now, hit the yes button for me. If I don't get everybody hit the yes button, I'm going to keep going. Hit the yes button if you want me to stop for today. I'm not sure if Alex is really still there. I think he might have lost connection. I'm worried about, all right, so some of you guys still don't know where the yes is. If you hit participants, you can see the yes, no, go slower, go faster. What about Yangsha? You haven't voted yet. I mean, if you don't want me to stop, I'll keep going. Yes.
Keep going.
Oh, you're not going to be very popular, I'll tell you this. No, I think I'll stop. I'm just trying to see who's really here. I think Alex got kicked off. Larissa, I don't know if you're out there. Oh, I'm sorry, Alex is there. You just got, you're stuck on the video. I don't know if Larissa's out there. Larissa wants extra work. Okay. It's freezing. Oh yeah, I got you. Okay, enough. I'm not going to worry about whoever's not really here. That's on you. All right, guys. So I'm going to put the quiz up right now. It's going to be on Canvas. If I were you, I'd go grab it now and do it. It's due by 11:59 tonight. Okay?
Okay, thank you. Bye.
Okay, you're welcome. Anybody have any questions? You want to hang out for a minute? You don't have to. You can head out. Go for it. Go ahead and log out. And again, I'm not really sure if some of you guys are even here. All right, I'm going to leave. I don't see any questions, so I'm going to close the room up. I'll see you guys later, whoever's out there. Bye.